So this is part of a bigger stream of activity on our end. So we've been in the last couple of months or 3 months, we've been experimenting intensively with lightweight approaches of getting linked open data and combining different data sets, integrating with third-party data sets, and doing something useful. And the baseline was all the time doing this within very lightweight integration and transformation efforts. I'll share some statistics. But to us, the major point is the technology that's currently in place good enough to allow you to do something useful, starting from Wikipedia or GeoNames or any other data set, normalizing the types of data that you care about and doing something useful with them. So that's part of this stream. The Panama Papers thing, it's provoked by the recent release of the offshore leaks database. So I will start over with description of this database, what it is in there, sample queries. Then I'll give you the bigger picture. This FactForge news, we call it playground, where we have combined multiple data sets and we do interesting things with them. But I'll start with Panama Papers database because it's the hot one. Let me before that say a few words about the one use case and scenario that we are trying to enable with this experiment. So on this picture, imagine there is a big bucks company, Big Bucks Cafe, that's located in Seattle, that controls my local cafe in New York through Global Investment Incorporated. That's at a place called West Bay. So imagine you have a database that gives you this type of control relationships. Imagine you can combine it with the geographical database that tells you Seattle is in Washington, Washington is in the United States, New York is in New York, which is in the United States, and out of a sudden West Bay appears to be a district on the Cayman Islands. So having the ability to combine these types of data and a graph database that can do all these inferences that you can see with the dashed yellow arrows allows us to easily, within very reasonable efforts, spot suspicious patterns like one company in the United States that controls another company in the United States through a company in an offshore zone. And then be able to get additional information about it, news, all sorts of things. So that this scenario is interesting to different players, but this could be a risk analysis manager in a bank where my local cafe is trying to get a loan, pretending to be an independent enterprise, while in fact it's related to Big Bucks Cafe. And for Big Bucks Cafe, there could be some news in the press telling you that, well, actually they're not in a very good financial shape. So this type of considerations can easily be enabled by relation discovery and discovery of related information by means of combining private data sets with linked open data sets, and that's what we are aiming at. So about the concrete database, as some of you probably have heard of, the International Consortium of Investigative Journalism have published on a couple of weeks ago a database, offshore leaks database, that contains information from extracted from the Panama Papers documents, but also information from an early investigation from 2013 about 100,000 offshore entities from these offshore leaks in 2013, and a bit more than 100,000 from the Panama Papers. So they may make these available as CSV files, comma separated text files, which are essentially extracts from a graph database. And they're available for download. The searchable database where you can play with some searches is on this URI. So what's in the database? It's essentially about companies, offshore companies, their owners, the shareholders, and other and shareholders, but also officers of these companies. There are intermediary companies which facilitate various functions and registration. These companies, for each of these companies, we also know countries and offshore jurisdictions that are relevant to this company. So that's in this database. What we did essentially was that we published this offshore leaks database as linked data. So it is available for exploration, querying, and download at this address, data.ontotext.com. For this type of data, it's important to make a disclaimer that we use the data as provided by the International Consortium of Investigative Journalism, and we make no representations and warranties of any kind, including warranties of title, accuracy, absence of errors, and so on, about the data. So all the transformations, queries, and derivative work are used to showcase the technology and not to make claims and statements. So on top of the barebone database, what we did was to essentially enrich the database. But let me first give you impression about. Just a second. Impression about what's in there in this database. Some of you who came earlier for the webinar were looking at this diagram. It shows the relationships and a number of the relationships between different classes of entities. Like there are about 2.2 million relationships between officers and entities. These are the offshore companies, and so on and so forth. But what's probably a better start is this diagram, which shows classes. So the bigger the circle, the higher up in the class hierarchy is this class. So leak nodes are essentially about 800 nodes extracted from the original database provided by the consortium. And there are nodes of different types. So you see some of them are entities, and we have almost 320,000 of those. We also have intermediaries, 23,000. We have officers, which altogether are about 350,000. And these are all nodes in the original representation of the data. We also have addresses. So each of you can play with this diagram. You can find it at data.ontotext.com class hierarchy menu. So these nodes in the original database are linked with edges, and there are about 1.2 million edges that connect to nodes. In the original database, those come like there are fields node 1 and node 2, which essentially provide the numbers of the nodes, and we have a little bit of further work not to basically interlink this properly to hash source and hash target. So to make a proper RDF graph. We made one more step because for each of these relationships in the original database there is a relationship type. In this case, it is intermediary of. So we took these relationship types and did a bit of work to classify them. because altogether there are about 80 or 84 of those, which, if you take them as a flat list, are not so easy to deal with. So we essentially said, well, there are two types of agents, agent being either person, either organization, that can be related to two types of relationships between an agent and a company. It's either an owner, either someone, an agent who serves the company. Owners could be, there are several, in the original database there are several different relationships that denote that's sort of an owner. You see beneficial owner, nominee beneficial owner, and so on. And there are many different types of servants and service providers of the company. We classified those into officers, service providers, directors, and some of them are nominees. So yeah, this is useful because if you're trying to follow change of ownership relationships, you don't want each time over and over again to enumerate all the relationships that can express ownership. In this case, we defined an ontology where we have all these the original types of relationships, like beneficial owner, represented as properties. But we have introduced additional super properties like owner and agent of and related agent that are automatically inferred because in RTF has given a proper database engine. The database engine can infer that if one of the more specific relationships is in place between two nodes, the more general one can be inferred. So that's one of the things that we did to make this database more easy to deal with. So this is the relationship type hierarchy. We made a proper taxonomy. The other thing was that in the original database, there are plenty of officers, everyone who serves the company in some way, and I think also the owners come in a file called officers, but you can't figure out which of those are physical persons and which of those are companies. So we did a bit of extra work to classify all those into persons and companies, and let me find the best place to show this now. And you see that now we have these 350,000, 45,000 to be precise, officers, of which 188,000 are persons and another 70,000 are instances. And there are about 100,000 officers, which, based on the data that is present in the database, it's not possible to figure out whether that's a person or a company, because in some cases the data is very laconic or missing. Like there are tons of entities with the name the bearer of, you know what I mean. So there are just names that can't be mapped to anything, but for those for which this was possible, we did it. But the most important part, the thing that adds most value to this database, is that we map the countries to the corresponding countries in DBpedia. Altogether, there are about 209 countries. So you see we have a country class, the country, and it has 209 instances. So this is quite observable. Everyone can basically take care of 200 entities to be mapped between two data sets. The more heavy lifting was to find a way to map companies and people from these Panama Papers offshore leaks database to DBpedia, so that we can get a bit more context about any of those, because in most of the cases, like in the original database, you don't have any information about the person or the entity apart from its name and eventually an address, which in many cases is some sort of an offshore address. So if you see Guangzhou, there are plenty of Chinese people in this database. You don't have any way to interpret and to figure out, well, what's this guy actually involved with. You don't have context. So being able to map at least some of those to DBpedia was crucial, because this allows proper interpretation of the data. Altogether, the data set is 20 million explicit RDF statements, and after materialization, inference that we perform with our graph database engine called GraphDB, we gain another 2 million statements. So it's not, for this data set, we don't perform very aggressive reasoning. As I said, the entire data set is available for download. I'll say a few words about the transformation process. The good thing, and something that we again was an experiment on our side, we transformed this data without any programming in a language like Java or anything. We used a nice open source tool called Tarko to transform CSV files using Sparkle into RDF. And then beyond that, we just loaded the data in GraphDB and used Sparkle to further interlink the data. The entire process is documented in a README file that contains plenty of information. You have a link here in the presentation, and you'll get the presentation. It's also linked from data.ontotext.com. And other artifacts like queries, scripts, whatever we use to work with this data and to generate the data, is available again without any limitations at GitHub at this address. So to me, the most remarkable thing in this exercise was that altogether, all the effort that we put in this mini project was in the range of 15% days spread across 1 or 2 or 3 persons. And that's including quite a lot of work that was not about the data actually, but rather setting up data.ontotext.com portal, promotion activities, documentation, this kind of stuff. So the actual work with the data was less than 10% days to get it to the point that you see now. So it's a good time to move to some sample queries. So if you go to, okay, luckily I have it elsewhere. Just a second. So if you go to data.ontotext.com, you have this welcome page that also provides you with the download link for the dump if you want to do this. You can get more information, learn more, and so on. But you have also the sample queries. So I'll quickly go through those queries. The first one of them is sort of an easy one. So let's see about across all sorts of entities. Just a second to minimize a few things. Across all sorts of entities, what is the distribution by country? So for anything that's in this database, we get the country, we get the query executed, and we see that Hong Kong is far at the top. Then you have the Virgin Islands, PVI, Then there are plenty of entities which are associated with the undefined country, so country is unknown. Then you have China, Switzerland, and so on. So one can easily modify this country by saying, actually, I don't want to do this with all sorts of entities, but rather with entities. And these are the offshore companies that are actually registered to perform some function, rather than officers and intermediaries. So if you take these statistics just about the entities, you see that in this database, BVI is by far the most popular one, followed by Hong Kong and Switzerland and Panama. We can also check what are the most popular I'm too lazy to type this. There is autocomplete that many of you can find useful. You press Control Space and you can choose it. So we get intermediaries, and again you find most intermediaries in Hong Kong, but then quite a number of those second and third place in United Kingdom and United States. So you see this picture is quite different across different types of entities. Let's proceed with the next query. So one thing that we decided to check is owners from which countries prefer which offshore destinations as a place to have a company. So we get a relationship between owner and an entity. It could be any of these different relationships variant that are in the database, and we also use the transitive variant of this relationship, which says the relationship could go across multiple steps. That could be a chain of relationships. So we get such pairs, owner and entity, and for each of those we get countries, the country of the owner, the country of the entity. We filter out the non-defined country, and we also say we are not interested in pairs where the owner and the entity are in the same country. That's trivial. Let's look at the other options. When we execute this, we get these results. The most popular combination of this type is that owners from China tend to register to own entities in Hong Kong, and then the second is from owners from Hong Kong tend to register to own companies in BVI, and so on and so forth. So you see these pairs, but generally you see that BVI is quite popular as a destination for the entity. Let's move forward. One statistic that we can get is statistic by year of incorporation of the entities. Let's better see this data as a chart. So in the GraphDB workbench, you have you can define charts so that just to have a better look at the results of a query. And you see that it generally starts somewhere in the 80s, and then it gets really popular, particularly with these two databases that we have in the middle of the 90s. And then the drop that we see here in 2010 is because in one of the sources, the offshore lake database, the data goes until 2010, so that's why the drop. Beyond this point, it's just one of the two sources contributing to the number of entities. Going forward, let's see. That's actually a query which was contributed by Ivo Velichkov, because we've been sharing these queries on Twitter, and then some people started suggesting queries, and we're very glad to basically adopt queries suggested by others to include them in a list of sample queries that other people could be interested in. Because we did a fair amount of work to publish this database, but we are not offshore company registration specialists, so there are a number of interesting things that we even can't figure out what questions we should best ask. So we are seeking for partnership both with technical people who are willing to do something on the data, but also on data analysts and investigative journalists who can give us good ideas of what type of queries we can do to the data. This one was contributed in a slightly different form by the gentleman Ivo Veličko from Brussels. And it essentially says, well, imagine there is a network of ownership relationships. Let's see which are the most connected nodes in this network. So let's get agents and anything that relates to the agent, either in one direction, either in another, with owner relationship. Get the statistics and see which are the most, in this sense, the most connected agents. Okay, it's telling me that it cannot represent it on the type of chart that I used for the previous query. That's not such a surprise. Well, so what we see is that, right there at the top, we see Portcullius Trustnet, somewhat limited, with 4,000 relationships of this type. That's quite a lot. And what we can also observe is that actually this name appears several times. So you have it here, but you also have it on position 6 and on position 7. So we actually see that in the original database there are duplicates that for one or another reason they didn't want to resolve. And there are nodes and different identifiers which represent one and the same entity. So one way to get an idea what happens is to here to perform grouping not by agent but just by the name of the agent. And then the numbers for these entities that have the same name will collapse. What appears is that, well, as I said earlier, you see that right there at the top, you get the bearer with 70,000 such things, and that's because there are plenty of entities that are different, registered on different addresses, owned by different people, who that have this fake name, and not fake but useless name. So if you ignore those, you see that again Portcullius Trustnet is right there at the top. So that's not a surprise because this is actually the service provider, one of the two service providers that were for which the offshore leak in 2013 was about. So back then, the database that's coming out from this source is essentially about Portcullius Trustnet and another one called Commonwealth something. Good. So yeah, let's move. That's not going to get more interesting this way. So one thing that we can do by combining this dataset with DBpedia and with geographic information is to ask a question like, let's see the owners of offshore entities in countries in Eastern Europe. So the query. For this type of query, you say, yeah, I need this type of relationships. Then I get the country of the owner, and then I want this country to be part of Eastern Europe. That's the GeoNames way of saying part of. when you execute this query, you see Russia getting very high at the top with almost 9,000 owners, and then everybody else is fairly small. Particularly, yeah, my curiosity, because we are based in Bulgaria, is that for Bulgaria you have 77 owners, and for Romania you have only 13. So it's either because Romanian people doesn't use offshore companies, either they're more careful in doing so. Anyway, that's just a demonstration. You can easily modify this query any way you want. So if we want to do Asia, that's straightforward. Yeah. No surprise, we get Hong Kong right at the top, Singapore, China. Well, I have no. Yeah, Cyprus appears to be sort of associated with Asia. That's probably okay. Good. Let's move to the next query so that we have more time for also other things. We can do search by the name of the entity, because so far you haven't seen a query that does search. Okay, here is one. With GraphDB, we have integration with multiple full-text search engines. One of them being Lucene, and this Lucene connector, it is part of GraphDB free, so everyone can take it and use it. And essentially, it's all about telling this connector what indices to create and what fields to have in these indices. In the comment of this query, you can find a link to the documentation if you want to create one. But now let's see how we actually use it. Just a second. So we essentially choose an index. In this case, the index that we use is onodes2. We define a query that, well, let's say Morgan Stanley, see what we have about Morgan Stanley. And the results of this query are bound to this variable node. And then for this one, we can put further patterns, right? We want it to be an intermediary. We want to get the name of this node, the country, and we want this country to be part of Asia. Let's see what intermediaries that have Morgan Stanley as part of their name we can find in Asia. We see Morgan Stanley in Korea, in Singapore, and the last one, the country is Hong Kong. So that's okay. So and again, obviously you can change everything you want in this query, like if I write Dresdner, for instance, we will get the Malaysian branch of Dresdner Bank. If you were curious whether they have Malaysian branch, yeah, they do. Yeah, let's move because we have more interesting stuff in the pipeline. So this was a demonstration of how we can integrate full-text search with normal Sparkle queries. Another interesting thing you can do with the data is to use the so-called RDF rank. So that's page rank applied. That's a built-in functionality of GraphDB, and that's page rank that's applied to an RDF graph to figure out which nodes are more important than others. So in this case, in the same way in which Google does it for web pages. So that's Graph Analytics, but it's built in and it's very easy to use because you just say, well, let's get all the officers, and then for each of them, let's get this is the special predicate to get this rank. Let's get the rank of the officer, and then let's get them ordered by this rank. And out of a sudden we get the BVI entity of right there at the top, which is not a surprise, but that's yeah, in a way, a very different way and sometimes more useful way of getting this. So if we want to do this not for officers but for entities, and to find out which is the most central entity, yeah, you can of course do it. You can do anything you want with these queries. It runs real time. We managed to get this ranking of all sorts of entities in about 3 seconds. So yeah, final query from this batch. Let's see how many of the officers are persons and how many of them are companies by country. So for each officer, we basically get persons, we get companies, we get the countries, and we group the results by countries, so that we get this. So that's not very attractive this way. Let's put it on a chart, and we need to change the type of the chart because this is not very readable to us. So that's a bit better. So yeah, you see that we have some peaks. Let's see what's in there. China. From China, there are plenty of Chinese people who are officers in such companies, 32,000 of them, and there are very, very few China companies that are officers. And then in Hong Kong, you have lots of officers, but also quite a sizable number of companies. Not defined is not interesting. Taiwan is again a place where you typically have physical people attending as an officer. If we investigate the red spikes, we'll see where is the typical location of officers which are companies. And yeah, BVI is by far coming up at the top. Jersey and Guernsey and all these sorts of offshore locations are right there. So you can find all these queries and play with them. If you go to data.ontotext.com, Sparkle, it opens up the Sparkle editor, and then you can click this folder icon, and you can choose a query to run. And then of course you can edit it any way you want. So this is everything about these sample queries. Now let's move on and to give you the slightly bigger picture. As I said in the beginning, we've been running this as part of a bigger stream of activity, a successor of something called FactForge that we relaunch soon. But before telling you more about FactForge, just a few words. Why are we doing this? Well, most of the time we are involved in data management projects, in content management projects, which are based on big knowledge graphs. So the way we usually do this is we combine different data sets, like typically a combination of some linked open data sets with proprietary data, taxonomy, thesaurus, whatever. We make a big knowledge graph. We use GraphDB to perform some inference to infer new relationships, and then we analyze the text to interlink the text with the data. At the end of the day, you have this big knowledge graph that you started with, along with some metadata and knowledge, like what we extracted from the text as relationship and which entities appear in which documents and this kind of stuff. All this in a single database engine, and you can query it, and you can do all sorts of interesting, like combinations of full text, search and structured, and other things. So we've been also we've been active in doing semantic annotation of text, or being able to automatically tag text. I'll show you a quick demo of this one. So that's a demonstration service that you can also play with. It's now.ontotext.com. I should probably make it a little bit bigger, which is fed constantly with new news from, I think it's sort of Google stream that we essentially process and interlink with these big knowledge graphs, in this case with Wikidata and with Wikipedia. So you see that we recognize all sorts of things within this data set. We also recognize like a relationship, like place of business, that Dollar General store is in Westminster, Colorado, which is a location on its own. For each of these things, we know how relevant is this thing, this concept to this article. We also know how confident we are that we properly disambiguate and recognize this one. And that's essentially based on the dynamic semantic publishing platform of Ontotext that's used by many publishers like BBC, Financial Times, and others. These type of annotations, they allow you to essentially export the text, then jump into to explore something concrete about one of the entities. United States wasn't the best choice because there are too many things about United States in this. But we can have a look at the target corporation. We don't have much additional information about it, but we know we have other news that are also related to target corporation. We have information about it from the graph, like who's the founder, George Dayton, and what sort of entities co-occur with target corporation. So it appears to be a sort somehow related to retail because we have Walmart. You can click any of those. You can see news that mention both Walmart and target corporation. You can again jump into the news and so on and so forth. So that's enough about it. I'm just saying that it's out there. It's a fairly mature technology, and we've been using this to extend our experiment. So that in FactForge News we have loaded Wikipedia geonames, some company registry data from the global legal entity Identifier initiative, and some news metadata from this service now. Altogether, that's about 1 billion of statements loaded in this repository, and I'll show you some queries and some stuff that you can do with it. The good news is that the Wikipedia geonames are linked to one another. This metadata about news is actually coming from this service now that processes about 10,000 news articles a month. And it's also generating metadata that's directly linked to a Wikipedia, Wikidata, or geonames. So it's all linked. On top of this, we have mapped the Wikipedia ontology and some of the other ontologies, like the legal entity identifier ontology, to FIBO, that's the financial industry business ontology, so that we can export this data through FIBO, because there is a growing community of people who want to do so. We have also run this RDF rank and several geospatial indices to allow all sorts of queries, but I'm not going to spend much time with this now. That's a couple of words about GLEI, Global Legal Entity Identifier. You can read more about it. The idea is that there is already a very serious organization and process going on to make all the infrastructure so that each legal entity on Earth will have a globally unique identifier that would, in all sorts of ways, contribute to transparency. So there is a dump of such data. We got it. We transformed it into RDF. This will be the next thing to publish. It contains information about 500,000 organizations. And there is also a lot of information about ultimate parents. So who is the ultimate parent of a concrete organization? So far, we managed to map about 3,000 organizations from this data into DBpedia. And yeah, but this was again a matter of a few hours, so we want to invest another few hours and get a bit more serious about it. We don't have much time to talk about FIBO, so I'll skip forward. I'll just mention that, yeah, the type of mapping that you need is to essentially define these relationships between the original schema or the original ontologies used by each dataset, like DBpedia ontology to map organization, company, person, and subsidiary to the relevant classes and properties in FIBO. And once you do this, you can essentially see all the data through the FIBO lens. So you can, for instance, on this diagram that I was showing you earlier, you can explore the class FIBO foundation etc. autonomous agent, and it appears to have 2.5 million instances. Most of those come from DBpedia, and you can guess this by the identifiers like DBpedia resource, Walmart, and so on and so forth. So that's an approach of like when you combine multiple data sets together, you need a sort of super schema to allow you to query this data and to deal with this data. And for most of the applications that we consume with this experiment, we find FIBO a very good choice. So we've been using this to perform the combination of all these information from DBpedia and other sources and the rich metadata about the news. We've been using to do some sort of semantic press clipping so that we can trace references not only to a single entity but also to related entities and to daughter companies, related people, and so on and so forth. We have also spent probably half a day to refine the industry classification that's available in DBpedia, because there are plenty of variations of how the different industry sectors are designated. There are different predicates used to connect a company to or organization to a sector, and so on and so forth. But within few hours of work, we've been able to make some extra layer on top of this, which is quite usable, and I'll show you some sample queries. So there are a few queries. I won't show to you all of those but you can play with them at FactForge News, .ontotext.com, ffnews. It's still in beta, so while data.ontotext.com is public and is officially launched, this one is still in experimental phase, but you're very welcome to play with it. So I'll play with some of the queries just to show you what's possible there. Okay, so one query that one can do is get the airports that near London. In this case, we get from DBpedia information that specific thing is an airport. We also get from DBpedia the longitude and latitude, and we use the geospatial plugin that's part of GraphDB to calculate nearby. Yeah, you get results quite easily. Something interesting is that it turns out that there are as many as 80 different airports within 50 miles from London. And then you need, it's quite useful to have a way to order them by importance so that you can make sense of them. And in this case, using this RDF rank is quite good because you see that if you order these 80 airports by RDF rank, you get those that you know about and most of them care about right there at the top. So all the big civil airports are come up at the top if you sort them by this rank. Then another thing you can do is to as I said, in DBpedia there is plenty of information about industry classifications, but also about the child-parent relationship. And we spent about a day there to again clean up and structure a bit this information. And now I can say the results are quite good. So you can say, well, I'm interested in Google as an entity. I want to get people that are related in any way to Google, and also organizations that have a parent relationship to Google, either parent, either child. This stands for inverse. You get it, and you see, well, again, because those are plenty, there are 94 of them. You get at the top some of those that are really the most relevant, so you can easily verify whether these results make sense. Going forward, speaking of industry classifications, we can check what is the amount of how are the different industries represented in DBpedia, and you see that finance comes right at the top with 5,000 organizations in the finance sector. Second is transport, and so on and so forth. So these are all sample queries. Again, for FF News, you can reach them out by clicking this folder diagram and playing with them. When we start combining this with news, we can say, well, let's see information mentions of a specific entity and people and organizations that are related to it. So we say, in this case, Gazprom, and we get people related to Gazprom and organizations to which Gazprom is a parent. Once we get from this subquery this list of related entities, we are basically making the right connections to the news metadata to get news that contain a mention that has an instance that has exact match with this concrete thing from DBpedia. And you get it. You see that we got a range of news. The most recent right there at the top, from one from 26th of April this year, that mention either Gazprom, either entities related to Gazprom. So there is this football club Zenit St. Petersburg that is owned by Gazprom. There is a radio station, Echo of Moscow. Alexei Miller was either the previous CEO or either the current one. I think he's the previous one, and so on and so forth. So and again, you can do this query and then change it with anything to see how it works. So if you want to check Berkshire, I'm too lazy to write it, so I can use the autocomplete. Berkshire Hathaway, run the query and see news about Berkshire and related entities. And well, here you are. You have quite a fair number of those listed, and you see that we have more than 1,000 news articles about Berkshire Hathaway and its related entities. So enough about this one. So one thing that one can do is to make statistics about, let's see, news that mention concrete entities, and these entities are from a specific industry. Like if we write automotive here, we get some rankings of automotive companies, and you can change it to anything you want. What is actually more interesting is the version of this query that also considers not only the entities in this industry, but also their daughter companies. And if you do this, again for automotive, you're getting a slightly a more complete and more interesting picture. I have made some statistics. So, for instance, if you do statistics for popularity in the news without considering the related companies, the children companies, you get this ranking that you can see on the left-hand side table. With the children, you see that actually the number for General Motors almost doubles. Volkswagen goes from 2,000 something to almost 4,000. And Tesla goes from number 2 to number 4, and so on and so forth. The data is there. From what we investigated, we find that this information this industry classification is reasonably precise and usable. So for banking, for instance, if you make statistics of direct mentions, you get Goldman Sachs and JP Morgan Chase right there at the top. If you include the related companies into this, there is something wrong with this first record, China Merchants Bank. But if you ignore it, JP Morgan Chase essentially doubles the number of references and mentions that it gets and gets before Goldman Sachs. So now the final thing that I want to show you on the technical side. Few queries that show how we mapped linked leaks to DBpedia and what's the result from this. Let me just find the right place to demonstrate this. Just a second. So the way we did the mapping, we basically have this sort of predicate between an entity in the leaks dataset and the DBpedia entity. So it's a mapped entity. So we can make statistics by persons and organizations. We see that out of 3,200 mappings, most of those go to persons, and the rest of them go to about 10% go to organizations. That's not a surprise because the names of offshore companies are most of the time chosen not to be very helpful, while the names of persons are usually the names of persons that don't change so much. So that's sort of reasonable. Another experiment that we made was to say, well, let's see out of all these companies that are already into this data set, how are the different industries represented? And you see that we have about half of these in finance, and then another 14 of those in real estate, which one can find obvious explanations why it works this way. If we want to explore a little bit, let's see what are the financial organizations that are mapped. We see plenty of banks. Canadian Imperial Bank of Commerce. Then one can say, well, why Caterpillar is there? Caterpillar, to the best of our knowledge, is equipment manufacturer, heavy equipment manufacturer. And that's indeed the case. You can browse this information, but it appears that in DBpedia it's also denoted, there is also this record saying that it's in the industry of financial services. So yeah, that's probably because they also have some investment activities or whatever. So that's just the way it works with the data. You see Dresdner Bank, you see Merrill Lynch that we mentioned a couple of slides earlier. Yeah, what else? The Union Bank of Switzerland, Royal Bank of Scotland, HSBC, one of their holdings, and so on and so forth. So, final thing, let's have a look at what we do with what sort of analysis we can do about people. This is a query that retrieves politicians that we managed to map. So you see, for something that's mapped to between the two data sets, and then you want the DBpedia entity to be related with any property to politician, and with any other property to a country, because yeah, there are plenty of different types of relationships that are used in DBpedia to connect a person to a country, or a person to its designation as a politician. So if you run this query, you get some 18 results. That's not too much, but it's still something. Aziz Aliyev, that's they are part of the big family of the dictator in Azerbaijan. That's there for a quarter century. But you also see a fair number of people from Italy and from other countries allocated here. We can also make this kind of query for athletes. In this case, we would want someone to be a first-class athlete. You query, then you see what athletes we find by country in this dataset. And yeah, again, you can explore all those. If you have access to the service, you can play with it. And that's probably everything that I wanted to show you as queries. Quick, going back to the presentation to wrap up, because we are just above the hour. So one thing we plan to do is to keep publishing data. So we will publish this linked open data RDF version of the legal entity identifier data as a dataset, again at data.ontotext.com. We plan to refine the dataset from the Panama papers that we refer as linked leaks as a hashtag, providing even more structure, grouping entities that are actually the same, providing a fiber mapping to it. And we plan to relaunch the FactForge portal, again with pretty much what I just demonstrated in the second part of the presentation. In terms of technical work for relationship discovery and developing the technology to do so, we will keep working on ultimate parent discovery and suspicious control pattern discovery. And also, because we extract relationships from news, we will combine all these data sources like DBpedia and then Panama leaks and then offshore leaks and then legal entity identifier data with information about relationships that we extract from news, because we extract hundreds of thousands of such relationships from these news that we process. We are actively seeking for partners, so we are already in conversation with a few of the top data providers, like Dun & Bradstreet, FactSet, Bureau van Dijk, read, and so on. Because all these things, it's good to be able to put in the mix the linked open data because they are free. But there are plenty of things that would work fairly much better if we also have the commercial data. So we explore partnerships with such providers to make joint offerings to essentially enterprises that quite often do use commercial databases anyway. We also seek partnerships with journalists and analysts because we need experts who can give us good ideas what to search for in this data. Because we are technology guys, we don't understand so much the financial affairs and the offshore affairs. So wrapping up, we published the Offshore Leaks database from the International Consortium of Investigative Journalism. We published it as linked open data. We also published mappings to DBpedia, and you are very, very welcome to play with it and to download it, and you can get a free version of GraphDB and load it in there and do your own project. That's really easy to do. We have also demonstrated how we can combine multiple open data sets and make good cases for discovery. It was really a matter of a few days to clean up and to further structure like the industry classification and the control relationships in DBpedia to get them to a level where they are fairly useful. And then also we showed how, not in this demo today, but with this platform, how we can layer a top-level ontology like the fiber ontology on top of all this. The really nice outcome is that we can easily add more data sets. So it's a matter of a few days or a couple of weeks to add yet another data set, be it the global link data identifier or linked leaks. So I expect that soon there will be more leaks. So we have more work and more fun. Thank you very much for listening. For those that were patient enough to stay to this point, we can probably handle a few questions.
So thank you very much, guys, for everybody who has stayed for so long. We're not going to take much of your time. We're just going to have a few questions answered by Atanas Kyriakov. I just want to mention, because we received a lot of questions, are you guys going to receive the presentation and the recording of this webinar? Yes, you are. You're going to get a link through the email that we're going to send afterwards, so don't worry. If you missed something or you want to use it for something, it will come to you, don't worry.
Okay, so to handle a few questions online, so there is a question from Aaron Sandhu. How do you map the data to RDF? Well, that's our secret sauce. No, there isn't anything that special. We use, in this case, for this kind of mappings between companies or from some company data source to DBpedia, we find a methodology to do this very, very well with Lucene. So we use the Lucene connector within GraphDB. So that we can easily filter out good candidates for mapping, and then to basically further qualify them by structured criteria and choose one. So we mapped these 3,000 entities from the Panama papers to DBpedia. I did it last night, to be honest. I mean, it was really a matter of 3 hours or 4 hours of effort. So that's one of the ways. In general, doing this type of reconciliation or identity resolution could be a very tough problem. So in other projects we use different machinery, but for this particular one it was very straightforward, just with the Lucene connector of GraphDB. What other questions we have? How was the ontology mapping alignment performed manually or automatically. I think I answered this one. How can I search if a specific person or a company is in the Panama Papers? How can I find all the relationships related to that entity? You can start off from this sample query that we had about intermediaries in Asia, where we've been using the Lucene connector to search for Morgan Stanley and then other things. Then you can just modify this query so that you search about any types of objects that you care about, with or without geographic constraints. So this would be the best starting point for you. Okay, that's probably enough. Once again, thank you very much for your patience. You can play with this semantic news portal at now.ontotext.com. Just to get a real feeling about the technology and how this can help you explore news, because you have all these knowledge graphs related to them. You can start using either GraphDB or our text mining pipelines right there in the cloud. We have a service called S4, which also have really good free quotas, so you can start your mini project or pilot without paying anything, just registering and getting an account. And of course, the stuff that we presented today, you can play with this Panama database, offshore leaks database at data.ontotext.com. Thank you very much for your attention, and yeah, looking forward.